recent years, a new shift of paradigm was promoted in regulation related to environmental and human health issues. The conventional approach, based on control of compliance with quality standards, is now enslaved to a more comprehensive risk-based approach. But what is risk assessment? What are its goals and how should it be performed? Risk assessment is the procedure in science-based decision-making that identifies and evaluates the stress on different receptors. In the case of environmental risk assessment, the target of the study is the environment, its habitats and ecosystems. In the case of health risk assessment, the focus is on humans. A threat to the environment or humans, referred to as hazard, can be any event, specific activity, chemical or microbiological agent that has the potential of causing harm. Risk is a prediction and a measure of the likelihood and severity of the potential adverse effects of the hazard. Risk assessment final goal is safety. Thus, it should be followed by risk control and management, by weighting alternatives and selecting appropriate actions, considering also technical, economical and political issues, and risk communication as integral parts of the decision process. Risk assessment and management approaches have a wide range of applications, including the design of regulation, for instance, in determining societally acceptable risk level, which may form the basis for the environmental standards, prioritization of risk, for instance, in the determination of which chemical to regulate first, or to decide how to allocate resources to the control of different types of risk, or providing a basis for site-specific decisions, for instance in land use planning or siting of hazardous installations. In the case of water resources, environmental risk assessment may be performed, for instance, to evaluate the hazard resulting from treated or untreated wastewater discharge into surface waters, while human health risk assessment may evaluate the effects of chemical and microbial quality of consumed drinking water or crops foods irrigated with reclaimed wastewater according to agricultural reuse practices.
Both environmental and human health risk assessments follow several stages, starting from the problem formulation, defining the scope and the boundaries of the analysis, and helping to make the risk assessment process transparent by explicitly stating the underlying assumptions. Then, hazard and exposure characterizations follow. Hazard characterization examines the potential hazard, such as the chemical or agent of concern, its toxicity, and the effects potentially associated with exposure. The dose-response assessment, based on toxicological studies, characterizes the relationship between exposure to a chemical, toxin, or microbiological agent and the incidence of undesired effects, such as environmental damages or the probability of infection or disease. The exposure assessment studies the environmental behavior of the hazard, the expected levels in the possible exposure media, the likelihood and modalities of exposures, including the amount, the routes, for example, ingestion, inhalation, and dermal contact, and the duration of exposure. The final step of the analysis is risk characterization, putting together all the information from the previous stages to estimate the actual risk by comparing the exposure levels to the acceptable ones given by the hazard characterization. And in case these levels are exceeded, possible mitigation measures are identified to reduce the risk at levels of no concern. Most risk assessments rely on mathematical models to estimate risk as a function of one or more inputs, for example, the fate and transport of a chemical in the environment, its build-up in the food chain, its toxicity, and the routes of exposure for humans. In most cases, precise knowledge of the systems to be modeled or even the scenarios to be evaluated is lacking. Furthermore, several parameters are characterized by inherent natural variations, diversity, and heterogeneity over time, space, or individuals within a population or life stage. Variability and uncertainty introduce error in risk assessments and lead risk assessors to combine science and judgment when performing analysis to support risk management decisions. Traditionally, risk assessment follows a deterministic approach in which risk assessors select a single value for each model input and generate point estimates of risk associated with a central tendency or reasonable worst cases. This procedure unavoidably ignores uncertainty and variabilities in risk estimates. The results, in most cases, may overestimate actual risks, entailing unnecessary risk management actions and higher costs. But even worse, underestimates of risk may also occur, implying inadequate protection of human health and environment. Probabilistic risk assessment, in its simplest form, is a group of techniques that incorporate variability and uncertainty into risk assessment by characterizing them in some or all the model inputs. With probabilistic approaches such as Monte Carlo simulations, risk assessors propagate input uncertainty and/or variability distribution through the model to produce distribution estimates of both the hazard and exposure levels, estimating the risk with its probability distribution instead of point estimates. Making uncertainty and inherent variability visible and estimating their potential contribution to the risk are the main advantages of the probabilistic approach, which also contributes to improving the transparency and credibility of the risk assessment procedure, even in the case of limited data. In comparison to the deterministic approach, the probabilistic assessment appears more realistic, providing an overall picture of risks in the population and not just of extreme cases. Furthermore, risk assessors can avoid worst-case assumptions, but using all the available information, they have improved possibilities in ranking issues and prioritizing mitigation solutions.